Hello, once again this is Mr. B, and today we'll be talking about factoring quadratic trinomials by grouping. Before we start talking about trinomials though, let's review factoring by grouping itself. So, if we've got a polynomial with 4 terms and we want to factor by grouping, I'm going to start out by grouping the first 2 terms and the last 2 terms. Then I factor out the GCF out of each pair of terms. So the GCF for these 2 terms is p squared. So when I factor that out, I divide each term by p squared, and so I get 2p. And 5p squared divided by p squared is 5. So I get 2p plus 5. The GCF for these 2 terms is 3. So when I factor out that 3, I get 2p plus 5 again. Now, if the stuff inside the parentheses is not the same, then you can't factor anymore, and you just put not factorable. But since they're the same in this one, I can continue factoring. I'm going to factor out the 2p plus 5 now. So what I'm left with is the stuff that was on the outside of the parentheses, which is p squared plus 3. And that's how you factor by grouping. Basically what we're doing is we're undoing distribution. So if you distribute this back out, then you'll get something that looks like this. Because you see, we multiply p squared by everything over here, then the 3 by everything over here, and we get that. And then when you finish multiplying it all out, that's what you get. So we're going to apply this now to a quadratic trinomial. Now, a quadratic trinomial in standard form looks like something times x squared plus something times x plus something else. So the problem that we'll have to start out with is that there's not 4 terms, so we can't group pairs. Alright, so what we're going to do is we're going to split up this middle term using these steps. So the first step, anytime you factor, you want to factor out any GCF. You don't have to do this first, but it really does make life a lot easier, or at least makes it easier to factor if you do that first. It'll make your numbers smaller, and you won't have to worry about it later on. So then step 2, we're going to use a table to figure out what factors of a times c combine to give me that middle term, that b value. So in step 3, we're going to use that table to split up the middle term. And then our last step is to factor by grouping. Feel free to pause if you need to copy down these steps. We're going to continue on. So here's an example. So the table that I'm going to use looks something like this. This is just a table I come up with to help organize things. Alright, so in this part right here, I'm going to put whatever a times c is. So my a value in this case is 1. My c value is 63. So 1 times 63 is 63, and it goes right there. In this column, I'm going to combine my factors that I'm going to write down here. So down here, I put all my factors of 63. So let me go ahead and do that. I'll start with 1 and 63. Okay, then we have 2 doesn't go into 63. 3 and 21. 4 doesn't go into 63, neither does 5, neither does 6. 7 times 9 is 63. 8 doesn't go into it, and then I already have 9, so I know this is all of my factors. Now, I need to combine these to get that middle term, and I'm going to use this, whatever operation this is right here, to do that. So I'm going to use addition this time to do that. Okay, and I need to get 16. Now you're not going to worry about the sign right here until we actually do the split. But keep in mind that we do need to get negative 16x, not positive. All right, so 1 plus 63 gives me 64, which is not the same thing as 16. 3 plus 21 is 24, which is also not the same as 16. 7 plus 9 is 16. So that's the 2 we're going to use. We're going to use 7 and 9. So I'm going to split this middle term up. The x squared is going to stay the same, but this 16x right here is going to split into a 7x and a 9x. All right, and so these two factors need to multiply together. 7 times 9 doesn't give me 63. It needs to be positive 63. But when I add it, it needs to be negative 16x, which means both of these need to be a negative. Okay, so when I combine like terms, I get that negative 16x. All right, so now I need to group and factor by grouping. So I make my two groups. Sorry about that. Let's go back to the slide. I make my two groups. Now, I do put parentheses to make sure this negative goes with the 9x there. But I'm still adding these things. So I'm adding a negative 9x plus 63 here. All right, that's just a little technicality there that I like to include just to make sure you're not changing anything. This is not multiplying now. All right, so I'm going to go through and factor out my GCF. So the GCF of x squared and negative 7x is x. So when I factor that out, I get x minus 7. The GCF of negative 9x and 63, well, I know 9 times 7 is 63, so that's going to be 9. And when I factor it out, though, looking at my signs, the signs in this one are positive than negative. The signs in this one are negative than positive. So I need to change these signs to make them match. The way I do that is to factor out a negative number, because that changes both my signs. So negative 9x divided by negative 9 is positive x. And then 63 divided by negative 9 is negative 7. So same thing inside the parentheses. So I'm going to factor it out. So we got x minus 7 times x minus 9. Okay, if you want to check your work, you can go through and distribute things back out, or use your box method or whatever you want. But this is going to be our final answer. All right, I got a couple more examples. So example 2. In this one, we have an a value that's not 1. It's 5. So when I do my table this time, this first one is going to be a times c. So 5 times 18. And don't worry about the sign. This sign right here is actually the thing we're going to do to our factors to get that middle term. So the middle term here this time is a 1. If there's not a coefficient, the coefficient's 1. All right, so 5 times 18 is 90. So I need factors of 90 that give me 1. Now, once you get good enough at this, you're not going to have to make the table. You can say, well, the factors of 90 that give me 1 are, and then, you know, if you think about it, you can figure it out. So until then, though, I'm gonna model what it's like going through it. So 90, that's 1, and 90. Those subtract to give you 89, though, which is not 1, so that's not going to be it. 2 and 45. Which when I subtract, and you always subtract the smaller one from the bigger one because the sign doesn't really matter right now. You get 43, and that's not it. 3 and 30, which subtract to give you 27, that's not it. Blah blah blah. I actually know the answer is going to be 9 and 10. Okay, so once again, as soon as you know the answer, you don't have to go any farther. 9 and 10. 10 minus 9 is 1, so that's going to be the one I use. All right, but if you didn't know the answer, then you could keep going. I just got bored because there's a lot of factors of 90. Okay, so I'm going to split this middle term up into a 9p and a 10p. So we got 5p squared. We're going to have a 9p and a 10p, and then it's going to be minus 18 at the end. Now, in order to combine these two and get negative p, the 10 needs to be negative and the 9 needs to be positive. A basic rule that you can use is that the bigger of your two factors here, or not factors, the bigger of your two terms needs to have this sign if when you combine them they're opposite signs. So if this one's minus, then these signs are going to be different. If this one's, whatever sign this one is, the bigger value gets that sign. Alright, so now I factor by grouping. So I group the first two, The last two, I'm going to put a little plus because there's a minus right there. And now I want to factor by grouping. GCF of 5p squared and 9p is just p. So when I factor it out, I get 5p plus 9. GCF of negative 10p minus 18. Now, signs are opposite, so I'm going to factor out a negative, and the GCF is 2. So negative 2. So when I factor that out, I get 5p plus 9. Notice it's the same thing inside the parentheses, so this is factorable. And so we get 5p plus 9 and p minus 2 as our answer. Okay, since we're multiplying, the order of these two don't matter. Let me just mention that. P minus 2 could be here, and 5p plus 9 could be here. It doesn't matter as long as you have 5p plus 9 and p minus 2. All right, we got one more example. Okay, in this one, the reason why I want to do this example is because there's a GCF that we should factor out first before we do anything else. All right, so looking at these three terms, you'll notice 4 goes into all of them. I'm going to factor out a 4, and also there's all three of them have at least n squared, so I'm going to factor out a 4n squared. And so what I get is 7n squared plus 4n minus 20. So now I'm gonna factor this part, and the 4n squared is just going to kind of chill on the outside. It's just going to hang out until the very end. Okay, but make sure you put it down in your answer, or else you'll get the answer wrong. All right, so I'm just going to factor out this over here on the side. 7n squared plus 4n minus 20. The reason why I'm doing it on the side is so I can not worry about my parentheses. All right, so I'm going to make my table. All right, so 7 times 20 is 140. I'm looking for things that have a difference of 4. Okay, so thinking about it, we've got 14 and 10 have a difference of 4. And they multiply together to give you 40. Okay, once again, if you need to do the table and work it out, just listing all the factor pairs, you can. Feel free to. Don't feel bad about that. I've had a lot of practice at this, so I can spot these factors. But anyway, we're going to split this middle term up into, so we got 7n squared. We're going to split it up into 14, so positive 14n and a negative 10n. So I'm going to do minus 10n plus 14n minus 20. So when I combine these two, I get positive 4n. So I'm going to group them and factor out my GCFs. So the GCF of 7n squared and 10n is n. So we get 7n minus 10. The GCF of 14n minus 20 is 2. So we get 7n minus 10. Okay, so the parentheses are the same, so we get 7n minus 10 and n plus 2. Now we can't forget about that GCF that we factored out. So our final answer is going to be 4n squared times 7n minus 10 times n plus 2. Alright, well, I hope this helped. Feel free to go to Khan Academy and practice their factoring problems using this method. They do teach another method, and if you know another method, you can use any method of factoring these quadratics that you want. Just make sure you can factor them consistently and get them right. Have a good one.